Dr. Andrew Steele is finding out how the seemingly magical properties of a classic child's toy provide the solution.
This is a gyroscope, and to explain how it works, we're going to need one of these.
A motorcycle's wheels do more than just power and steer it.
A gyroscope works by conservation of angular momentum, which means that when it's spinning around very, very quickly, it doesn't want to change the direction of that spin. And this can give some pretty counterintuitive effects.
These physical reactions can be extraordinary. An effect known as ghost riding can occur when a bike crashes and loses its rider, but then rights itself and continues its journey. This phenomenal sight is down to gyroscopic forces, such as gyroscopic precession, acting on the bike to try to maintain its original orientation. So how does it work?
Well, I'm going to try and show you with this piece of apparatus here. What we've got is an ordinary bike wheel, but we've filled the inner tube with concrete just to make sure it's nice and heavy. So currently this thing isn't spinning, and that means it hasn't got any angular momentum. And that means it's pretty easy just to make it spin around. It's not very stable. However, if we get this electric drill, we can get the bike wheel spinning. And as we add more speed with the drill, we're increasing that angular momentum. Now it's moving very fast, and now if I give it a whack, you can see this thing is stabilised.
And that's why, in extreme circumstances, a wheel can refuse to lie down. Astonishing as this is, it was the stabilising effect of a gyroscope that maritime engineers were interested in.
If I get it spinning nice and quickly, I can just balance the spinning wheel on my hand.
Just like a spinning top stays upright, perhaps gyroscopes could do the same for a ship. In 1917, American inventor Elmer Sperry used the effect for the very first time in a large vessel. He equipped the USS Henderson with two enormous gyro wheels weighing 60 tons. Inside, 3-meter flywheels spun at an incredible 1,100 revs per minute, creating huge amounts of angular momentum in order to minimize the ship's roll. Although a huge engineering breakthrough, his brute force approach ultimately proved impractical. And as technology has developed, so has the use of the gyroscope.
Over the years, pioneering scientists and engineers have experimented with these gyroscopic forces to the point where nowadays we can fit tiny gyroscopes on the surface of a computer chip like this one. And they're used everywhere, from mobile phones to aircraft and even ships.